Hello, so in this video I want to talk about projective geometric algebra, goes by PGA. Sometimes it's called plane-based geometric algebra. There's some distinction there between the two, but I actually don't really know what the distinction is yet. But I'm just going to call it projective geometric algebra. And so it's a very elegant way of, well, doing, it's actually not necessarily for doing projective geometry, but well, right here I guess it is sort of projective in the sense that it's being rendered onto a two-dimensional plane, but that math for the projection is not actually being done here. That's in the rendering, I think. But anyway, it's a more useful, more elegant, more efficient method of doing geometry than anything else that's ever existed before. And just to talk about that briefly, this is a YouTube thumbnail actually from, there's this video, A Swift Introduction to Projective Geometric Algebra. And Sudgi Lakmo, I believe is the, you can see the name of the YouTuber there. And, well, it takes all of these complicated formulas and creates these. And so this bottom one is projection. It's a dot product followed by, I think that's just an ordinary what we call the geometric product. And this is a wedge product and a regressive product. And what's great is that these formulas, these three formulas on the side, on the right side, are the same for n dimensions. It doesn't matter. I don't know about the one-dimensional case, but for 2 dimensions and above, it's going to be the same same operations that give you this stuff. And whereas otherwise it would be this mess, and this mess on the left changes as you change dimensions. So it truly is a mess. You've got the cross product and dot product and all this stuff in here. And on the right, this is going to end up being what's called a join and a meet. So those are terms from, I see those terms usually in projective geometry, joins and meets, but I don't know that it needs to be projective geometry. But anyway, yeah, so it's going to be this great simplification of things. And indeed, for this in the browser, I'm dragging this around with the mouse. So it's giving me this 3-dimensional picture. I can zoom in apparently. I don't know how to pan yet. That'd be nice to be able to do. But yeah, so we've got a triangle and a point and a line segment and a line. And actually I can drag this around, and in projective geometry there's this duality of lines and points, and so that is a theme in all of this. Okay, and so there's 2 files here. So for those who are familiar with HTML and JavaScript, you can go to you can find the Git repo here, and you can figure it out. There's also this, if you search online coffee shop ganja.js, there's a bunch of basically demos, demonstrations here of various kinds. And I wish they would add some much simpler examples at the top, to be honest. But if you want somewhat simple examples, I guess rotors and translator. What else? Yeah, I don't know about I haven't really looked too much at the 2D ones, but maybe, yeah, there's a rotor and translator one here. Now, something that really interests me is this dual quaternion thing. So you can drag this. So this is the bad version, which you get from just, I guess, linearly interpolating some kind of twist. But this whole dual quaternion thing is kind of what I'm after at the moment. This stuff is so elegant that you can actually do origami relatively easily, which is pretty fascinating. This would be all kinds of crazy equations, which it kind of is, but it's only 57 lines. These are not like excessively long lines either. So for what it's doing, this is incredibly compact and elegant. And in this demonstration, which is working on the computer, yeah, it's not that much. Most of this is just comments, okay? So there's actually not that much math. It's a bunch of basically declarations and just a tiny bit of math, more or less. Okay, yeah, so for those who are familiar with HTML and JavaScript, you can go here. Now, and also PGA is a little complicated. So later, after I show how to get this working, for those who are not familiar with HTML and JavaScript, then I will briefly talk about one of the complicated things here that you need to understand to dive into all of this. But yeah, let's talk about how to get this working. It's very simple. But I'm going to start by right-clicking and creating a text document. Now, if you're on a Mac, it's funny, just creating a little file on a Mac is rather annoying. You have to bring up whatever the equivalent, is it WordPad or whatever the simplest text editor is. You have to open the application and actually create a file if you're on a Mac. I don't think you can just right-click and go to new. Okay, so this is just text. So I'm going to just rename this. Let's call it, I'm just going to call it tut. But the file extension I'm going to change to HTML. And yes. Code at the end of the day is just text, really. And the file extension really just is a hint to the operating system of what application to open it with. If I double click here, it will open in Firefox, but you can always go like this, make sure it's going to open in where you want it to. Now it's not doing anything, it's an empty document right now. Let me see if I can just drag this in here. Is that possible? Yes, I can. Cool. So I'm going to use Sublime Text, which, well, now it's just called Sublime, I think. Sublime 3 or whatever, but this is just editing text. You can use any text editor or code editor or IDE or anything. We're just editing text here. Okay. It is easier if you give the file extension .html so that your browser doesn't complain. But at least in Sublime here, I can just go angle bracket HTML. Now that it has, Sublime also is using this file extension as a hint because it's giving me this like snippet. I can just press tab, it gives me this, so that's nice. Now, if you look here at the instructions for getting this going, it gives this script which has a URL. Now, if you were actually, it used to be this kind of thing would work, but lately, in the last several years, security is taken more seriously on the web, and I think that this will not run locally on the browser because it's what's called a cross-domain reference or something. So for security reasons, it doesn't like that. So all I'm going to do is I'm going to take this URL and I will simply open it up right here. And I will take all this text and I want to paste it in. But let's see, I'll just make actually, I'm going to make it here. So again, new. Don't do this rich text document. There might be some extra header, blah, blah stuff in the file that you don't want. So just do this simple one. And here we're going to call it ganja.js. Again, I know that for people who are familiar with HTML and JavaScript, it's like, why are you making this video or whatever? But okay, I already have one. Let me, just for demonstration, I'll get rid of this. But not everyone is familiar, people aren't born familiar with HTML and JavaScript, so I thought I'd make this video to make it a little more accessible. So, okay, so I have this file now. Just so happens I can just drag this in, I believe. So but you need to open this with whatever text editor you're going to use or code editor or whatever. And now can I paste? I think I used my copy paste. So I'm going to copy and paste. There we go. So now I have this JavaScript file locally. I'm going to press Control S to make sure it's saved. And same, well, this one now for the HTML file, now it's just going to be ganja.js. Now this assumes that the HTML and JavaScript are in the same directory on your system. So if you had some other file, like a folder called JavaScript, for instance, you would need to, or a file called JS. Sorry, if ganja.js were in a folder called JS, you need to do this. But they're right here next to each other. So this is sufficient. And I'm going to save that. So now this will load in the JavaScript file, but it's not going to do anything. Now I can open this up. Let's just demonstrate that this doesn't do anything. But anyway, yeah. So now all we do is, actually if you scroll down to the bottom on the repo page, the README, we have a Ganja starter kit for PGA 2D and also PGA 3D. So pick whichever one you want. You can copy paste this. And we need actually a script tag. So I'm going to do angle bracket script and tab. So it looks like this. Of course, you can just type this out if you're just on a normal text editor. And now I'm going to paste this in. Didn't quite indent the way I want. I'm going to indent this. Oh, wrong button. And yeah. Okay, I'm going to save that. And this should be enough, actually. So let's just check that. I'm going to refresh this. Fuck. Okay, so I refreshed this and now here it is. Now I can, at first this looks 2D, but I can actually drag it around. Do this kind of stuff. So I don't know, for me, I want to do some work with projections, projecting 4-dimensional objects into 3D, and I've decided this is the way I want to do it after looking at several different options. So that's what I'm going to do, but I thought I'd just share this, how to get started easily for those who maybe aren't so familiar with HTML and JavaScript. You can, now it's sort of working. Now you can go in here, you can read the documentation on the repo. You can go in here and change things. You can look here at other examples that may interest you. They have like, what, physics planets orbiting each other. So I'm guessing this is just using a inverse square law to calculate gravity. I'd be curious if it's doing all of the gravity between all of them, or if it's just between the planets and the sun separately. I'd have to look at the code. But yeah, we've got like differentiation of vector fields and all this amazing stuff. Yeah, one of the Clifford algebra things, it gives you differentiation, sort of this thing called automatic differentiation, which is pretty amazing. But yeah, and then I was going to explain one of the more complicated bits. Now, if you dig deep into all the videos out there about projective geometric algebra, this will come up. So it's not new, but we have, so what we're doing with this projective algebra is we have a linear combination of 3 basis vectors. So I probably should have done this in a different order, but it's, so let me forget about this for a second. If we are talking about a line, so we're going to talk about the linear space of lines. It's kind of a prerequisite for making sense of the PGA stuff. it's going to be x plus y plus c equals 0 is our general equation of a line, and we just look at this and we say, well, that looks like a linear combination. So we say, why not? We now define a line as this linear combination of these three basis vectors. So we have an x component of some basis vector x, y component, these are just labels, of course, and so forth. So the E1, or sorry, let's do, well, yeah, so the E1 will simply be the x equals 0. Because if we have one unit of the component of one of this unit vector, E1, we'll just have x, and these ones will be 0, and it will equal 0. So that gives us this vertical line. That's going to be white there, so I need to change that. Okay. Vertical line there. X equals 0, right? And so our so that was E1. And E2 is just going to be the line y equals 0. Now, if you do something like E1 plus E0, this is basically like x plus 1 equals 0. And so that's going to be the vertical line going through -1. Similarly, if you had E2 plus E0, it's going to be the horizontal line through -1. Now, E0 is a little, E0, I guess I should say, is a little tricky. So this is actually turns out to be the line at infinity. And if that is an uncomfortable concept, look into Riemann spheres. And I can't remember if stereographic projection necessarily has that concept, but yeah, the line at infinity is a concept that comes up. And well, why? I'm going to kind of demonstrate why that happens. So basically, if we have E1, some amount of E1, for example, and we have, so let's just call this A. And we have the unit E0. And we vary this we vary this A, and we look at what happens to our equation of a line. Well, so when A is 1, we have the line I already showed you, because that's just going to be x plus 1 equals 0. So that's the equation, that's the vertical line through x equals -1. But now, so let's say we make A into 1/2. What will happen is, I believe it will be this line going through 1/2, but let's double check that. So 1/2, 1/2 x plus 1 equals 0. So I think I messed that up. Did I start by saying 1/2? Yeah. So this will be 0 when x is 2, -2 rather. So it went the other way. So if it was 2x plus 1 equals 0, then it would have been the one I thought it was. But then as you kind of go off to infinity here, so let's say you have 1/10 x plus 1 equals 0, then when x equals -10, this will be satisfied. So you can see that this line is blasting off to infinity. And when A goes to 0, it will be the line at infinity. Yeah. And, okay, so yeah, there's a lot of interesting stuff to look at and think about there. I mean, I think of it as being sort of hyperbolic geometry there. But Anyway, that is what I wanted to demonstrate, because this is a little bit this linear space of lines is a little tricky to wrap one's head around. So I thought I'd just share that's kind of a prerequisite for this more complicated stuff. That's about all I wanted to say, I think. So have a good one.